Hope you're all doing great. Is everyone here? I think I will start. The ones that are going to come will find us. I hope everyone is doing great. So for today, before we go any further, we're going to have a brief revision on the things that we did last time. So we're basically introducing the chapter of nomenclature, and nomenclature looking at the alkenes, the first hydrocarbons in organic chemistry. So we defined alkenes to be in two classes. So there's what you call alkenes that are linear. These are straight chains that are open. Then we also have alkenes that are ramifié. They are branched alkenes. So we said when you are naming an alkene, there are rules that you're supposed to follow depending on which type of alkene you are looking at. So for the alkenes that are linear, basically the rules that the first three you're supposed to follow is reg number 1. For a straight chain alkene that is not substituted with alkyl groups, you're just supposed to count the number of carbon atoms, then later on define it according to the general formula that is the prefix, chain principal, and the suffix. So now, with further study on alkenes linear, we discovered to say, no, what if the alkene is linear and is substituted substituted with an alkyl group? How do you name it? So rule number 1 still remains, which is you define the longest continuous chain. Then you are also supposed to define the substituent. So like I said last time, the substituent is, in the case of alkenes, the substituent is the alkyl group with 1 hydrogen atom less. That is from the alkane. Then later on, you are also supposed to look for the position of the substituent. Is it closest to the, which part is closest to the substituent? Is it the left-hand side or the right-hand side? Then I remember last time in school, we had an error that was corrected by Blessings. We said when you are naming the alkenes, the root will be the route that you take, that is, if it's left, you take it left in that direction. If it's right, you also take it right in that direction. That's how you count the number of carbon atoms. Then the last one where we ended was, take for instance, you have an alkane that is ramifié. Then you have 2 different substituents. Take for instance, methyl and ethyl. So we said you are always supposed to arrange them in alphabetical order, regardless of the index. The index is the number, which is reg number 3, the position of the substituent. The index just shows you where the alkyl group is positioned, but the methyl and ethyl, which are the alkyls, are showing you which one comes first in alphabetic order, that is d'après règle 4. Then règle 5, which we're going to start today, is what happens when you have 2 or more identical substituents. What happens when you have 2 or more identical substituents? So it's the same principle. We are going to apply all these rules. Then where règle number 5 comes in, I'll surely highlight it. So far, are there any questions or any queries? Maybe you want me to explain on something before we learn something new. Okay, it's like there are no questions. Yeah, so Last time we defined what alkyls are, which are alkanes with one hydrogen atom less. So we have examples here. So the systematic name of an alkane that corresponds to that having one carbon atom, that is from the general formula. If it has one carbon atom from the general formula, we're going to say 1. Then 2 times 1 is 2 plus 2, that gives 4. That is now what you guys call methane. So now when you have an alkyl, it's the methane with one hydrogen atom less. So it no longer becomes methane, it now becomes methyl. So the suffix at the end, ane, will be removed and will be replaced with YLE. And the formula also changes. It no longer becomes a CH4, but becomes CH3. Why? Because you have one hydrogen atom less. Same applies to ethyl. Ethyl comes from ethane. Ethane is C with 2. When you come here to the formula, this becomes C2. 2 times 2 is 4. 4 plus 2 is 6. So the general formula becomes C2H6. Now, that's the ethane. Now, the the alkyl group becomes ethyl with one hydrogen atom less, and the number of hydrogen reduced. Instead of them becoming 6, they are now 5. This is 3 plus 2. So sometimes, depending on how the professor is going to teach you at your schools, these alkyl groups may be represented in this form. Methane can be written as Me. Methyl can be written as Me. Ethyl can be written as Et. Propyl can also be written as PR. So then we looked at alkanes ramifié last time. So this was an example from my presentation. So the first two states, you're supposed to look for the longest continuous chain. And the longest continuous chain, when you just look at this, it's automatically the longest continuous chain is this whole thing here. This whole thing is the longest continuous chain. But we can still confirm because we are learning how these rules are applied. So you start, so you say 1, 2, 3, 4, 5, 6, 7, 8, 9. You want to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then say this is 12, this is 9. It'd be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's automatic that this one here has the highest number of carbon atom and will be called the chaîne principale. Now, question number 2 will be, where is the substituent, or what is the substituent? The substituent in this case is this one here. Now, what's the name of the substituent? So when you're counting, because when you're counting, you go like this: 1, 2, 3, 4, 5, 6. So this is a carbon atom. You don't count this one when you're counting your substituent carbon atoms. No, because you've already counted this one to be in the longest chain. You do not count it when you come here and say 1. No, your 1 starts from here. Say 1, 2, 3. So 1, 2, 3. This is propyl. So it is propane with one hydrogen less. So it becomes propyl. Then rule number 3. Rule number 3 states we are supposed to look for its position. Now, you look at it from either from my left or from the right. So from the left, is it on position number 5 or position number 6? So you count. So you say 1, 2, 3, 4, 5, 6, position number 6. And start from this side, you say 1, 2, 3, 4, 5, 6, 7. And rule number 3, talking about or explaining about the position of the substituent, states that you're supposed to at least give the substituent the lowest number possible, the lowest index possible. in this case, the lowest in this, is it 6 or 7? 6 is less. So it will be 1, 2, 3, 4, 5, 6. Position number 6, you have 1, 2, 3. This is a substituent with 3 carbon atoms and with 1 hydrogen less. So it's going to become a propyl. Then the name will be position number 6. You have this. It will be 6-propyl dodecane. Dodecane for 12 carbon atoms. So I'll re-explain. So rule number 1 is you look for the chain principal. Chain principal is the one that contains the highest number of carbon atoms. Chain principal is the one that contains the highest number of carbon atoms. So you start counting, say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then you're not supposed, okay, this is a general rule. You're supposed to count all of them, but we know that this is the longest chain. Just by looking at it, you'd find that this is the longest chain. But you are supposed to count all of them, all possible chains. You can have this one that goes like that. You can have this one that goes like that. You can also have this one that comes like that. So you're supposed to count all of them. So this one here goes 12. This one, it goes to 1, 2, 3, 4, 5, 6, 7, 8, 9. This one goes to 9. And this one here goes to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you find that this one here, the one that is linear, has the highest number of carbon atoms. So rule number 1 is look for the chain principal. Then later on, we go to rule number 2. So we've defined what chain principal here is. It's a 12. It's a 12. It's a chain that contains 12 carbon atoms. And when you go to this table here, it shows that the one that contains 12 is called dode quelque chose. So it can either be a dode alkene, alkyl, and alcohol. It depends. So in this case, we just know that the prefix for 12 carbon atoms is dode quelque chose, etc. So now we know that this is a 12 chained a chain that contains 12 carbon atoms. Rule number 2 states we are supposed to look for the substituent. In this case, the substituent is this here. So I said when you're counting, because when you're counting, you're going to start say 1, 2, 3, 4, 5, 6. So position number 6 is ruled out when you're counting your substituent. You're not going to count 1, 2, 3. It's like you're counting this carbon atom twice, but you only have 1. So you count from here. You start from here and say 1, 2, 3. How many do we have? We have 3. And we said the substituent is also known as an alkyl. An alkyl, like I said last time, it's an alkene with 1 hydrogen atom less. In this case, it has 3 carbon atoms. So lucky enough, we have this one here, which is 3 carbon atoms and 1 hydrogen atom less. So this substituent becomes a propyl. Rule number 3 states we are looking for the position of the substituent. Now this position should have the lowest index or the lowest number possible. The lowest number possible. So you can either start from this side or from this side. So we start from this side. You find that it's going to be 1, 2, 3, 4, 5, 6, position number 6. And we start from this side, that's going to be 1, 2, 3, 4, 5, 6, 7. So you find that at position number 6, when you compare 6 and say compare 6 to 7, you find that 6 is lower than 7. It's just common mathematics, common logic. 6 is lower than 7. So automatically the index for this substituent will be 6. So the name now becomes, at position number 6, you have a propyl, which is an alkyl. Then the chain principal, we say the chain principal is made up of a prefix and a suffix. So the prefix in this case is the do, de. Then the ken, or the ken here is the suffix that shows that this thing or this chain we're talking about, this hydrocarbon we are looking at, is an alkene. Is an alkene. Any questions? We go to the next example if there are no questions. So now there's a question that was raised later on after the previous school. Say, is it always that you're going to have a methane in your chain? Then my response was no. It depends with the question that you have been given. Now in this case, we have this chain here, and we are taught to name it. So first of all, don't look at these answers I wrote here. These are the correct answers for these chains, but you are not supposed to just look at them and say, no, it's 8 ethyls, 4 methyl, 7 propyl. No, we're supposed to understand where these names are coming from. Yeah, the answers here are correct. So we'll just follow through and just prove that this answer is correct. Maybe it might be wrong, we don't know. Yeah. So the first rule states that you're supposed to look for the chain principal. Chain principal in this case, just by looking, just by looking. But like I said, you are supposed to count all the chains that are that can be possible. You can have this one that goes like that. You can have this one that goes kumuluko. You can have the straight one, and you can also have this one that comes like that. You can have this one, but all in all, the chain principal is this one here. Now we'll count to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 is the prefix, also known as the chain principal. Now you go back to this table. This table here shows that the prefix ou bien the chain principal containing 13 carbon atoms is called tridec quelque chose, either an alcohol, an amine, amide, an aldehyde, etc. But in this case, we are discussing the alkenes. Yeah. So the chain principal in this case has or contains 13 carbon atoms. So this is our chain principal. Rule number 2 states we are supposed to look for the substituents. In this case, we have 1, 2, 3 substituents. So the first substituent has got 1, 2, has got 2 carbon atoms. So 2 carbon atoms in the form of an alkane, it forms Fn. Now we are saying an alkyl is also known as a substituent. So when you lessen the number of hydrogen atoms, it now becomes methyl. Oh, sorry, ethyl. It was ethane. Now we remove 1 hydrogen atom, it becomes ethyl. So we are saying this contains 2 carbon atoms, and if it contains 2 carbon atoms, it's supposed to form this here. Where is it? It's supposed to form this. If it contains 2 carbon atoms, it's supposed to form ethane. Now we are saying because it's a substituent, we are going to lessen the number of hydrogen atoms. Now, when we lessen the number of hydrogen atoms, we change this suffix from ane, that signifies that this is an alkane, to yle, to show that it's an alkyl. So it becomes ethyl. If you want, you can write it in this way. This is a écriture semi-développée. So if it was compact, it would have been CH3, it would have been C2H5. So that is écriture compact, it would have been C2H5. So écriture semi-développée is CH3CH2. Rest of those things you guys have not forgotten, because they are the things that you'll be finding every time. So basically, they usually like écriture zigzag because it's the simplest to write. It's the simplest to write. So they'll give you formula zigzag. I think someone sent you guys something in the group that shows nomenclature and the responses to the nomenclature. So you find all those types. You find the ones that are in the form of écriture abrégée, écriture semi-développée, écriture développée pleine, compact, ou bien topologique. So rule number 2, we come back here. So rule number 2 states we are supposed to look for the substituents, which are also called alkyls. In this case, we have 3, like I said. We have one here that has 2 carbon atoms. We have one here that only has 1. And we have the other one, the last one, which has 3. This is 1, 2, 3. So we are saying this is ethane. Now with 1 hydrogen atom, it now becomes ethyl. Then this is methane with 1 hydrogen atom less, becomes methyl. Then this is propane with 1 hydrogen atom, it becomes propyl. Now, rule number 3 states we are supposed to look for their positions. We are supposed to look for their positions. Now, you start counting either from the left or from the right. When I say left, from left, right, it's conventional because we have this chain that is the longest in this way. Now, take for instance, you have a chain that is long and it's going like that. It's not, it no longer becomes left, right. It now becomes from the top to the bottom. So left, right is because the longest chain is in this orientation, from your left to your right or from your right to your left. It's not a general rule that you're supposed to start from left to right. No. The rule here is that we are starting from left to right because our longest chain, in this case, with 13 carbon atoms, is oriented in the left-right manner. Now, in this case, we are saying we are supposed to look for the positions of the alkyl groups. So we start, we say 1, 2, 3, 4, 5, 6, position number 6, and this is position number 7, 8, 9, 10. So we are going to have, this is 6, 7, and position number 10. Now, we are also going to start counting from the other side, from the other side. So we say 1, 2, 3, 4. So now, when you just reach here, 4, compare this in this, or bien compare the position of this alkyl group to the position of this alkyl group. That's the simplest rule. That is in other words, that is rule number 3. Look at the position of the first alkyl groups that you're going to find. The first one here is at position number 1, 2, 3, 4, 5, 6. At position number 6. The other one is at position number 1, 2, 3, 4. And we said it's a shortcut. The shortcut is what we are looking for. So automatically, this one here becomes the principal substituent that we're going to use as reference for these other positions. So because this one here is at position number 4, it's going to carry the names of, it's also going to help us determine the positions of these other substituents. Not this one, but this one. The reason why we are not taking this one here at position number 6, because when you compare 6 to 4, the index 4 is less than the index 6. Like I said, we are supposed to make this formula as simple as possible with the lowest index possible. Now, in this case, 4 is lower and 6 is higher. So we are going to take the right, this is the right orientation. We're going to name it from this side. That's position. That's rule number 3. So rule number 3 states we are supposed to look for the positions of these alkyl groups. In this case, we have methyl at position number 4. We have ethyl. Before we go to ethyl, we have propyl at position number 1, 2, 3, 4, 5, 6, 7. At position number 7, we have propyl, and at position number 8, we have ethyl. Now, before naming this compound, or bien hydrocarbon, we are supposed to now go to rule number 4. We are on rule number 4. Rule number 4 states we are always supposed to arrange these alkyl groups, substituents, in alphabetical order. In alphabetical order. That's rule number 4. Rule number 4 states we are supposed to arrange them in alphabetical order. So in this case, which one comes first? E, M, P. So when you look at the response here, E comes first, followed by M, followed by P. So the numbers here, the numbers, some of you might be maybe thinking, the numbers have nothing to do with these two positionings. You can have, you've seen, this is how this is a typical example of a kind of question I want to respond to. Like you have seen here, this is 8 and this is 7. then you have a 4 in between. The numbers are never, it's not conventional, they are never supposed to be either in alphabet, or sorry, in ascending order, descending order. No, numbers appear the way they are supposed to appear because they are dependent on the positionings of these substituents in the alphabet. So in this case, someone might think the formula was supposed to be, because we said maybe from this side, it was supposed to be 4, 7, 8. No, it's not like you're increasing or decreasing. No, it's because the 8 or beyond the ethyl is at position number 8 and is the first one in the alphabet. That's the reason why we have the 8 comma thingy here. So it's going to be 8 ethyl. Why? Because ethyl is on position number 8 and E comes first in the alphabet. Then after E we have M. After M we have P. So at position number 4 we have a methyl, and at position number 7 we have a propyl. Therefore, the chemical will be the nomenclature for this compound will be called 8-ethyl, 4-methyl, 7-propyl, 3-decene. 3-decene with 13 carbon atoms. With 13 carbon atoms. So the same principle is applied for this one. So we have a chain principal with 13 carbon atoms. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So rule number 1 states we are supposed to look for the chain principal. Rule number 2 states we look for the substituents. Now in this case we have 2. That's a methyl and a propyl. Methyl and an ethyl. So no matter what, we count either from this side and from this side. But just by looking, you know that this one here will carry the lowest index possible. But we can confirm. You say 1, 2, 3, 4. Say 1, 2, 3, 4, 5, 6, 7. So the question is between 7 and 4, which one is the lowest index? It is definitely 4. So it's going to be 4 methyl, then set 4 methyl and set ethyl. Now, because we are going to apply rule number 4, which states we are also supposed to consider their arrangement in the alphabet. E comes first, then M comes later on. So it's going to be, now position number 7 has ethyl and E supposed to come first in the alphabet. It's going to be set ethyl, 4 methyl, 3-decene. Any questions? Alhamdulillah. Now it's the same thing. It's the same thing. Right? It's the same thing for these examples. It's the same thing. It's the same thing. Now I just want to bring in another example. Now the question that I asked, this was the question I asked. Just a minute. So we are done, right? I was just giving a review on the first 3 rules. Now we are on rule number 5. Rule number 5 states, or quotes, what happens when you have 2 or more identical substituents? What happens when you have 2 or more identical substituents? So what happens when you have 2 or more identical substituents is you use the rule of multiplication rule. If you have got 2 that are appearing at the same time, you consider them to be 2. So now in organic chemistry, we don't say for a day or bien something like that. If there are 4, we say for a cat. We don't say, maybe you say, for example, if there are 2 methyl groups, and you put them in brackets and say this is being multiplied 2 times. No, we have special prefixes that are used for multiplication factors, like rule number 5. So in a case where you have a compound or a hydrocarbon with 2 or more substituents that are identical, that are identical. Rule number 5, that are identical. This is what you do. You follow the same rules. It's the same chain. Rule number 1 states we are supposed to look. So these are the examples. Rule number 1 states we are supposed to look for the chain principal. So the chain principal is rule number 1. In this case, we look for rule number 1's chain principal. That is 1, 2, 3, 4, 5, 6, 7, 8. So 8. 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7. 1, 2, 3, 4, 5, 6, 7. Now, most of you might be asking me, why is that every time you're counting, starting from this side? You can either start from this side. It's the same thing. You can start say 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4. So automatically we know that this one here is our chain principal, and it contains exactly 8 carbon atoms. So you go back to your table. I know you guys have done this in your organic chemistry from Zambia, but it's just another recap. So the one that contains 8 is called octa, either be it an alcohol, octanol, aldehyde, octanol, cetone, octanone, thio, I won't say the name, but this is the prefix for a compound or a hydrocarbon that contains 8 carbon atoms. So the chain principal in this case is octa, etc, because we do not know the suffix. But now we know that what we're talking about or what we're discussing on is alkenes, which are ramifiés or bien linéaires. So rule number 2 states we are supposed to look for the substituents. So in this case, the substituents that we have, because we say this is the chain principal, we have this one here 1, we have this one here 2, we have this one here number 3. So we have 2 identical substituents. So now we take note of rule number 5. So we go to rule number 3, which states we are supposed to also look for their positions. Now, which one is the shortest position here? Is it this one here, 1, 2, 3, or 1, 2, 3? So we know that, okay, this is 1, 2, 3, position number 3, and this is position number 1, 2, 3. Now the question comes here to say, okay, which one is going to be the first one? So because we all know that the route from left to right is position number 3, and 3 is the lowest in this direction, and when you come uku, you find that it is also in the lowest. It's also 3. Okay, in other words, you have a 3 here, and you also have a 3 there. Now, what you do for a case like this one is you continue counting. You say, okay, if this is position number 3 and this is also position number 3, let's continue counting. You say, okay, this is 1, 2, 3. You have an ethyl there for 5. On position number 5, you have a methyl. So we are saying at position number 3 and at position number 5, we have at position number 3 we have ethyl, and at position number 5 we have methyl. Then we do the same on the other side. So we're going to have 1, 2, 3. At position number 3 we have a methyl, and at position number 4 we have another methyl. Now the question would be, which one has the lowest index possible? Is it the one that has 3,4 or the one that has got 3,5? So when you compare 3,4 to 3,5, it's automatic that 3,4 is the one having the lowest index. Now 3 and 3 are at par. That is 3 for position ethyl and 3 for position methyl. Now what determines which one we're going to use is now the other index. The other index here is 1, 2, 3, 4, 5. Position number 5 shows us that we have a methyl. Now when you come on the other side, you have 1, 2, 3. Position number 4 shows us that we have another methyl here. Now when you look at 5 and 4, which one has the lowest index? It's the one with is it 4? Yeah, with the one with 4. Then automatically, when naming this compound, we are going to take this route. So it's going to be 1, 2, 3. At position number 3, we have a methyl. At position number 4, we have another methyl. At position number 5, this is 6, we have ethyl. We have an ethyl there. We have an ethyl. Now, the question would be, normally, we are supposed to go to the last one, which is alphabetical order. We know that the E is going to come first. Then later on, we are going to have the M that is going to come first. Now, that happens when you have only one substituent that is not repeating or that's not identical to the other. Like this one here. In the other example, we had 3 that are different. So we were supposed to end at rule number 4, which explains the principle of the alphabet. Now, because we have rule number 5, which states when you have 2 identical substituents, you are supposed to use the principle of multiplication. Multiplication in this case is denoted or represented by what you call the tetra, penta, tri, d, all those things, to just show that you have 2 of these that are appearing in this hydrocarbon. So in the case where you have 2, you are going to say di. What is it? Here. In the case where you have 2, you're going to say di. In the case where you have 3, you're going to say tri. In the case where you have 4, you're going to say tetra. In the case where you have 5, you're going to say penta. In the case where you have 6, hexa, goes on, ends the suite. It's just the same principle as this one here. When you have 1, it's normal. It's the normal. When you have 1 of these, it's the normal name. It's going to be propyl, butyl, pentyl, hexyl. But when you have 2, it now changes. When you have 2, it now becomes something like this. Now becomes, for 2, it becomes di instead of do. It becomes di. For 3, it becomes tri. For 4, it becomes tetra. For 5, it becomes penta. For 6, hexa. For 7, it becomes hepta. For 8, octa. For 9, it becomes nona. Now for 10, it becomes uni, deca, deca, then NC, the suite. So for this one, for this molecule, is it this one? Yeah. For this one that has 2 that are appearing, we're going to use the multiplication prefix, which is we have 2 that are repeating, that is going to be di. So the name will be, we still apply the alphabetical rule. We always apply the alphabetical rule. The alphabetical rule states we're supposed to arrange them in their order of the alphabet. Now in this case, which one comes first in the alphabet? This multiplication factor here does not affect the alphabet. This here is just to show that there are 2 of these. So when naming it, we are still going to apply the same principle. E comes first, then we have M. The di here is just a multiplication factor to show that we have 2 identical substituents. So the name would be 1, 2, 3. At position number 3, we have a methyl. At position number 4, we have another methyl. At position number 6, we have an ethyl. So as usual, E comes first in the alphabet, then you have M later on. The name will be at the nomenclature. For this hydrocarbon would be 6-ethyl 3. And when you're naming them, you put these dashes. So you say ethyl dash 3,4 dash dimethyl. The di shows that you have 2 methyl and octane. Then the reason why we use the multiplication factor here is to save us the hassle of writing. No matter we can write, we're supposed to write this, if we're just like applying these rules blindly, we're supposed to say, okay, 3 is the one with the lowest in this. Okay, it's going to be 6-ethyl, 3-methyl, 4-methyl, octane. Now, to save us this trouble or the hassle of writing 3-methyl, 4-methyl, we use the multiplication factor, which is the di, the tetra, the penta, etc. So in this case, we are going to say at position number 3 and at position number 4, we have the same, or bien an identical alkyl group. In this case, we have 2 methyl groups. So at position number 3 and at position number 4. So we go to, this one is a bit straightforward. We go to this one here. So this one here, we still apply the same rules.
So I have a question.
Okay. I thought there are no questions.
Just on this same first one. Can you please repeat why you chose to count from
this side?
Count using the using the ethyl. Yeah, why you chose to count from the right?
Okay.
Can you just repeat that for me?
Okay. Is it clear? Any other questions? So that I explain everything ensemble. Any other question? Okay. So we redo this one. Rule number 1 states we are supposed to look for the chain principal.
Just read on the on this one.
Just this one.
My phone was repeating.
Okay. So I'll repeat everything like how it flows. I'll repeat everything how it flows. So how rule number 1 comes in and other things. So rule number 1 states, but I'll be a bit fast. So rule number 1 states we're supposed to look for the chain principal, and the chain principal can be this one. We can either start from this. It's the same thing. So we said this was our chain principal, and has how many? 8 carbon atoms. 8 carbon atoms. And it's going to be called octa quelque chose. So now in this case, because we're explaining or discussing on what's this? We're discussing on alkenes. It's going to be octane automatically. Now we are saying rule number 2 states we're supposed to look for the substituents. In this case, we have how many substituents? We have 1, we have 2, we have 3. So this one here is a methyl, this one here is a methyl. They are identical. This is an ethyl. That's a methyl. These two are methyl, and this one is ethyl. That's rule number 2. Rule number 3 states we are supposed to look for the positions of these alkyl groups. That's where Esther's question comes in. We are supposed to look for the positions of these alkyl groups. Now, the question is, we are looking for the positions. Now, we start counting in any direction, either left to right or right to left. So we start time. We say 1, 2, 3. At position number 3, we have a substituent. Okay? At position number 3, we have a substituent. Then we come on the other side. We say, okay, 1, 2, 3. At position number 3 on core, we have another substituent. Now the question would be, now we have 2 substituents at the same index. We have 2 substituents with the same index. We have 1 with 3, and the other one is also having a 3. Now, I said, now this is, get me clear, Esther, on this one. I said, when you are looking at equation that has, like you have 2 substituents, like this one here, you have 2 substituents and are having the same index. What you do is, you continue counting, You continue counting. Say, okay, this is going to be 1, 2, 3. At position number 3, we have a what? We have what do you guys? Let me use a PowerPoint presentation to just give more detail. What I'm trying to explain here. So So we are saying, can you guys see the presentation, the Microsoft presentation? If you can't, tell me.
Yes, we can.
You can?
We can.
Alhamdulillah. So I'll draw the structure. Make a draw. You can't access okay here. So the molecule looks something like this. The molecule looks something like this. No, it's not a molecule, sorry. It's a hydrocarbon. So we are saying we are going to count, right? So let me use a highlighter. So we are saying our chain principal is this one, right? This is our chain principal. It has got how many? It has got okay. It has got 9 atoms of carbon. It's got 9 atoms of carbon. So we are saying we are supposed to count also, or we are supposed to look for the index. Now, the index that we have here in this,
it's 1 o'clock.
We have okay, let me use another color.
Daliso.
Huh? You guys can see?
Excuse me, Daliso.
Yeah, yeah.
You say the longest chain has got 9 atoms of carbon. Is
Oh,
it
sorry,
9 or
8. Oh, 8. Sorry, yeah, but 1, 2, 3, 4, 5, 6, 7, 8. Thank you very much, Tonga. So it's going to be 8. Sorry. Even if 9, we can still, the answer is still going to be correct. With 9 carbon atoms, not with the 8 ones. So we are saying we are supposed to, let me just get a color to just show you the index. So there's this one here. I'll use 2 colors. This is for position number 3 in this direction. This is position number 1, 2, 3. Then this is position number 3, number 4, number 5. So we have 5 here. 5. So we change color for the other. So we are saying here, Esther, this is, please get me right on this one. We are saying we are going to do this because we have found that at position number 3 and also here at position number 3, we have 2 substituents with the same index. Now, to just differentiate, just like a representation to just differentiate the 2, I'll say 3 prime with a prime on top like that to just show the difference, that there's a 3 here, another 3. I can also say 3, but just show the difference. So you're saying at position number 3 you have ethyl, and at position number 3 you also have methyl. Now we are saying we continue counting. Okay, we'll start from the, this is left. Oh, this is right. This is from the right. This is from the left. So from the right, we say, okay, we'll continue counting. Say 1, we have 3, and we have 4 here. So this is going to be called 4 prime. I'm using the prime to differentiate. So now the question would be, we can even write them down here. We say 3 prime, virgule, 4 prime. Then and write this here. 3, 5. Now the question I'm asking now is, you see, the rule number 3 states we're supposed to look for the lowest position possible, the lowest index possible. And the lowest here, we find that it's 3 and also 3 here. Now the question is, now how are we going to know that this one is supposed to be the one we are supposed to use? Now, because these 3 and these 3 are the same, they are having the same index, they are the same. We are going to go to the other index. That is, for the one moving, or the one we're counting from the right, this is our left. The one we are counting from our right has an index of 4 for the other substituent. Then the one we're counting from our left has another index at the 5th carbon atom. Now my question is, which one between the two, 4 5. Which one has, or which one is the lowest? Which one is the lowest? It's 4. Esther, is it? It's 4, isn't it? Esther.
Yes.
It's 4. So now, because 4 is the one having the lowest, in this rule number 3, d'après règle 3, which states the position of the index should be as small as possible. As small as possible. 3,5 and 3,4. Which one has the lowest index possible? It's 3,4. So when naming this compound, we are going to orient it in this, excuse me, in this manner. It will be 3 prime, 4 prime. Then later on, we are going to now look for the position of this substituent here. So we are saying automatically, this is the route we are going to take. Let me highlight it also now with a different color. So this will be the route we are going to take. This will be the route we are going to take. Now, considering that we're going to take this route, the positions for this one will be maintained. This is going to be 3, this will be 4. This one no longer becomes 3. This is another thing that Mr. Blessings last time corrected on. Thank you very much, Mr. Blessings, once again. So this here, no longer we're not going to call it 3, we're going to call it position number X. Why? Because we are supposed to count and find out what position it is. This is going to be 1, this is going to be 2, this is 3, this is 4, this is 5, and this is position number 6. So the name of the compound, the name of the compound would be at position, then not forgetting rule number what? You guys, let's hope you guys are following these rules, right? Rule number, which one is it? Rule number 4, which states we are supposed to also consider their order in the alphabet. Now, before going to the order, we are supposed to also look at rule number 5 that states if you have 2 identical substituents, in this case, we have 2. We have 1 here. Sorry, let me draw again. Okay, highlight another color, pink. So we have this substituent here that is identical to this other substituent here. So when you have 2 identical substituents, you are going to use the multiplication rule. Now, the multiplication rule here is not putting everything in brackets and saying for deux. No, we are saying we have multiplication factors in organic chemistry, and these ones are tri, ou bien tri, tetra, di, hexa, octa, etc. to just show the number of occurring substituents, or bien the multiplication factor of these substituents. Now, in this case, we're going to apply all the rules together. We're going to apply all the rules together and attack this question. So the first rule is chain principal. It contains 8 carbon atoms. So let me just add another page. Let me come here. Can I wrap this? Or maybe it's needed. Okay, I'll just write it. Okay. Okay.
In this same structure, seeing as we are counting the position of the substituents from the left and the right, yes. So why can't we, like, for this one, the one with 1 carbon, the ethyl, there, yes. Why didn't we like count the other one too, like the one that's facing upwards?
This one?
No, this one is like from the right, the substituent.
This one from the right. Which one is facing down? This one?
The first one.
This one?
No, the other one.
This one?
No.
This one?
No.
Which one?
The other one, that's second pink. The one on top, the one that's
the second pink.
Not that one, the other one.
This one?
The next one. The next one to your right.
No. Show me. As in, you tell me at what position you are talking about. At position number what?
Okay.
Position number.
The third position from the right.
This one?
Yes.
And why didn't we consider?
Why didn't we consider it? Because here you're you just got the position, the prime position, and the position of this, the methyl, the Alcène, yes. the Alcène, and then you also considered one of the methyls. You didn't really focus on that one. Why didn't you focus on that one when you were counting the bonds?
Why did I focus on this one when I was counting?
Yes.
As in counting, like naming these indices or what? I considered this one also. Like this is what I did. Eh? I did this. It said 1, 2, 3. This is position number 3. Tape. So this is position number 3. This is the 4 prime. Now, then we have 1, 2, 3, 4. We have another methyl at position number 4. Now, now we're looking for, in other words, we're looking for, now which one is going to take the name, or which one is the root we're going to use for this compound. Now, we are saying, because the two have the same index, we have one here that is at position number 3, and we also have another one here at position number 3. We'll be like, okay, now which one are we going to use here? Is it this one or this one? Then d'après régulatoire, which states we are supposed to look for the lowest index possible. We are going to continue counting on either side. So if I continue counting on the left, I'm going to have 1, 2, 3. At position number 3, there is there's a substituent there, which is the ethyl. We continue counting. Okay, number 3, number 4, number 5. At number 5, we have another substituent. So now for this one, we also continue counting. Right? I think your question is, why didn't I put this one here? Let me put it maybe to just show clarity. Right? Let me do this. Where is the file? Rubber. Okay. Let me just redo this, right? So that you follow where I come from with the index thingy. Let's hope everyone is following, right? So this is 3, 5, maybe I also include this one. So 1, 2, 3, 4, 5. So 3, 5, 6. Maybe if I include this one to be a bit clear. So we have 3 prime. We have 4 prime. And we have 1, 2, 3, 4. This is 5. This is 4, 5, 6, and 6 prime. Maybe this like this would be a bit clear. So we are saying we look for the lowest index possible. Now in this case, the lowest index possible we have 2 directions that we are considering here. The reason why we have 2 directions we are considering is because we have found that the first 2 index, the first 2 substituents that we are looking for have the same index. In this case, the index that we have is 3 here and another 3 there. So now we are supposed to now look at which one has the, like rule number 3, which one has the lowest index. So I said when we are looking at it from the right, we continue counting. So okay, this is position number 3. We have a substituent there. At position number 5, we have another substituent there. At position number 6, we have another substituent there. Then we also consider looking at it on the other side. Now we're going to look at it from the right hand side. So from the right hand side, we have at position number 3 prime. To just differentiate, right? To just differentiate the 2. I've used prime and the other one without the prime. So this one here, position number 3, we have a substituent there. At position number 4, we have another substituent, and at position number 6, we have another substituent. Now, what is going to help us is looking at which one has the lowest indices. Now, we have 3 and 3 there. Just a comparison. We have 3 and 3 there. So we can cancel out the 3. So I can say we can cancel out the 3. What color? Red. This is red. Okay, anyway. So we cancel out the 3. We cancel out the 3 there. Now, which one is lower here? Is it this or this? So we are saying 4 is lower, 5 is high. So we say okay. 6, which one is lower? It's the same thing. They are all equal. So we can also cancel this one. We can also cancel this one. So it means this one here is ruled, this one is overruled. Because when you're counting from your left to your right, the one here having position number 5, or the one with index number 5, has a higher index as compared to the one here when you're counting it from the right hand side. It has got an index of 4. So it now becomes like this is the root we are going to use. We are going to use this root because it has the lowest indices possible. We have one here at position number 3. We have another one here at position number 5, or 4 at position number 4, and we have another one here at position number 6. Now, when you name it in this way, it will show that this one here has the highest indices at 3, at 5, and at 6. So, Taonga, the reason why we were counting from this side is because when we look at this, when we look at this hydrocarbon, the lowest indices possible we can find for this one are in this orientation. Now, how did we come about with this evaluation on the answer? It's because when we compare the indices, this is 3,5, 6, to that of 3, 4, 6, we find that at position number 3 and 3, okay, we say these two are equal, so we overrule them. Then we have 5 and 4. Now we say which one is lower between 4 and 5? It's 4. So we consider taking 4 and eliminating 5. Then the last one, which is 6 and 6 are equal. So because we have one here, we have one tick. This becomes the general. These are the general indices we're going to use. So is that clear, Taonga?
Yes.
Okay. So now, okay, you're welcome. So now we are saying we are now going to apply all the rules. We're going to apply all the rules. So this is a 8-carbon chain molecule. So we are saying at position number, applying also the alphabet, at position number 6, we have, at position number 6, we have at position number 6, I think these diagrams, for now we can move them. Anyway, at position number 6, we have ethyl. It comes first in the alphabet, ethyl. At position, we're using these. Just look at this. You can even forget about this diagram. At position number 6, we have ethyl. Now we are saying, we are naming them, please. These two dashes, you put these dashes. Ethyl 6 dash ou bien hyphen. Ethyl at position number 3, 4. We have two methyls. Now we use the multiplication rule and say di-methyl. Then la prefix de la chaîne principale plus suffix. So we have octane. Oh, no, not octane. Octa. Then the suffix is ane. Therefore, the name will be, when you cancel the thingy together, it now becomes octane. Any questions? So now just summarize, right? Just summarize so that maybe it becomes clear for everyone. So what I'm trying to say is this is the new rule that we have for today. The one that explains or just gives highlight on substituents that are double, triple, quatre in a hydrocarbon. So if the number of substituents here were to increase, for example, we had another one, another methyl, we would say 3 because they're now 3. If we had another one to make them 3, we'll say 3. If there were 4, we'll say tetra. And we're going to arrange the numbers in that order. We're going to say maybe 3, comma, I'll use letters A, comma, B. Because there are 4, we're going to say tetra, because there are 4. Now here in this case, this example, we have 2. So we are saying di. The same principle applies for the other side. It's not like because it's only ukuno. It also applies on the other side. We can have A, comma, B, comma. See, these A and B's I'm using are just to signify the indices that we might have, right? It's nothing like no it's a molecule A, comma B, comma C. No. When we look at stereochemistry, we will now learn how to name these compounds using letters like 1S, 2RS, all those things. Now, for now, this is a basic. We'll say A, comma B, comma C to just show that these might be the number of indices we might have and how many of these substituents are repeating. So in this case, we have got 1, we have 2, we have 3, we have 4. We are going to say tetra. If we had 4, tetra, ethyl, quelque chose comme ça, something like that. If we had 5, same thing. So we're going to have C, D. So say penta, ethyl, shingana. So are there any questions so far? Any questions?
Yeah, Daliso. In the example we had ethyl and the dimethyl. Is it that the di doesn't affect the alphabetical order arrangement of the? Is it?
Yeah, the di does not affect the alphabetical. Which one comes first between A and D in the alphabet? It's D, def.
Yeah.
But now, if you look at the formula that we've given here, we've used E because like I said in the explanation I gave, the di is just a multiplication factor. It does not affect the alphabet. So the di is just like in other words, what I'm trying to say is, let me just give a mathematical representation of this. Let me just give a mathematical representation of what I'm trying to say. So we're saying this molecule, what is this? This molecule here, 1, 2, 3, just do anything, right? So okay, let me just if I say these things so that we have a bit of space. So what I'm trying to say is this molecule here has got 2 identical substituents. Let me put 3 to just emphasize on that point. Let me put 3 identical, 3 identical, right? 3 identical. Maybe I should put 4. So 3 identical substituents. So now we're saying if there are 3 identical substituents, no matter if it was mathematics, we would say this is 3 times methyl. I hope it's visible. Methyl. Methyl. There are 3, it's 3 times methyl. There are 3 methyls that are appearing in this hydrocarbon. So in mathematics, this is how you're supposed to represent it. No matter. This is how you're supposed to represent it. Now I said in chemistry, instead of us saying, okay, this formula is going to be 1, 2, 3, 4, 5, 6. So that's hexane and position number 1, 2, 3. So at position number 2, at position number 3, and position number 4. So it's going to be 2, 4, 2, 3, 4, try. Now, we are saying in chemistry, instead of us saying 3 times, like the formula, like the name here, like I'm saying, is supposed to be 2, 3, 4, try, or be a 3. But in mathematics, representations like this, we don't say try, we just say 3 times methyl. The methyl formula, the shortcut I showed you guys, methyl can also be represented by Me. So this here just shows, okay, this might be correct in mathematics, but in chemistry, this is wrong. We show if occurrences or consecutivity of 3 or more identical substituents with these multiplication factors here. We don't multiply using numbers, the normal whole numbers, no, because we understand to say that the indices here for the substituents here also show show the whole numbers here show the positions of the substituents. Now, if you put another 3 here and multiply it with a methyl, it's going to be like, I don't know what's going to be. But the idea is, for such compounds, we use, for compounds that have occurring what's this? Substituents. We use the multiplication factors, which are di, tetra, penta, etc. Is it clear?
Yeah, it's clear.
Alhamdulillah, alhamdulillah. So now, before we even close, time is still there. This is 13. This is 13:24. Are you guys exhausted?
Yes.
Yes, we are.
The way you guys don't refuse.
Very much.
Let's finish now. Let's finish. So if we don't finish, then it's some kind of overnight food to seek. May want to rest. So we go to the last one. Now the last one is. Do you guys first of all, before I even go any further, did you guys do the research on how to name these things? Did you guys do a research? Be honest. If you didn't do, please just say you didn't do. Did you do a research? I just said you do a research on how to name these things. Did you guys do a research?
On nomenclature?
Yeah, on the three functions, on the 3 hydrocarbons. These ones, alkenes, alcynes, and alkenes. Did you do a research just on how to name the basic ones? That's even just a 2-minute YouTube video, or maybe just 1 page of a PDF. Did you do a research on that? Yes or no? We continue. So that I continue. Yes or no?
Yeah.
Yes.
Okay. Silence means no. So this thing I'm going to explain here, please take it very much serious, because it's the same thing we are going to use for these guys. Alcynes. These ones here, the triple liaison. So I will make sure I summarize both at the same time. I'll teach both at the same time, simultaneously. Now, this is how I'm going to do it. Because guys, Nina ka. So at next time, when we come, we start doing it, benzene. Can you guys see my presentation?
Yes, we can.
Alhamdulillah. So the first one will be, no, let me use PowerPoint. So far, how are the quiz going? All the quiz. How is the analysis going? You guys are not doing analysis.
C'est compliqué.
Complicated. Who's doing analysis? Who has answered? Who's saying it's complicated? So we say, no, I want to report it to your professor. Just mention your name. Even your initials, even your nickname.
Analyze nyoka wa boss.
Organic chemistry. Is organic chemistry sio cover?
Yes.
Ai, organic chemistry sio cover. Okapa ni kabise. Ni kabise. Kapea ni kabise.
No.
Organic chemistry is your cover. Guys, you understand when you are able to understand something, which means at least.
Sio cover.
This one is okay. Analyze.
Analyze. It doesn't have a specific issue.
Unaenda kanisa organic chemistry ni kabisa first 9 hapa. At least tilingane na analysis. So ati mkabokrasi organic chemistry ungasika mbati. No. This one is complicated. It's complicated. And I also saw that one that posted something. The one I posted in the group, the post I posted in the group. Ati madabache mutu na nankan not connected. Guys, no, don't worry. Things will be okay at the end of the day. Don't worry. It's just that you are learning these things for the first time. When I'm doing like methane, you just know that methane is CH4. Yeah. But Savali, you just have to continue studying. You guys, I'm told, I actually was told that you guys are starting school in when is it? Someone in September. So, in October. So I think you still have time to to read through these things. Watch videos. If you don't understand, I know you have professors' contacts, Shanshan Oko. Please ask them. That is why they are there. Why is this failing? That is why they are there for you. Yeah. So if you have a question, please ask your professor. No, why is it like that? So you understand, because if you just take it that no, analysis is hard and you're not asking questions, it's going to end up being hard just like that. At the end of the day, you'll be like, no, I wasted my $3 in the first instance. You wanted to even refuse paying $3. You'll be like, no, I wasted it. I would have used it for something else. Classes, but we shouldn't be the case. The case should be, if you do not understand anything, even you guys doing organic chemistry, if you do not understand anything, because today my target was supposed to finish all these things today, like I was supposed to finish all of these things. Now I'm supposed to make sure that you understand why these things appear to be like that. Because at the end of the day, I don't want a situation like that. No, there's wasting a time. There's wasting a time. I don't want. At the end of the day, I want people to pass. Even 4-9. So now, too much talk. We go back to work. So now, all the rules, from alkenes to alcynes, alkyls, we are going to be applying the same. It's the same rule. It's the same rule. It's just that on this one we just add another one. On this one, the first 5, where you have. I'll start from the bottom. Where you have 2 or more substituents, we multiply them. If you have 2, we say die. If you have 3, we say 3, or bien try. If you have 4, you say tetra, etc. If you're going to position number now, you're going to rule number 3. Rule number 4. Sorry, rule number 4 that explains the order in which they occur in the alphabet. Then rule number 3, which also highlights more on which one you are supposed to consider. Is it from the left-hand side? Is it from the right-hand side? The positions of the indices. But you are supposed to take into consideration that the lowest index is what you are following. Then rule number 2 is you are looking out for the substituent. I started from the bottom. And rule number 1 is la chaîne principale. La chaîne principale. All these rules will be applied. We'll be just changing things. We'll be just say, okay, no, this is an alcohol, so we'll do this. This is a what, we'll do this. This is a what, we'll do this. So now, for alkenes, SP quoi, hybridisation. This one, what type of hybridization is this? Fast. Hybridization, what type is it?
SPD.
SPD, angle. The angle is between the adjacent
120 degrees.
120 degrees. The type of shape it forms, is it the structure? Theoric. Is it triagonal? Is it tetraedric? Is it linear? Any answers? Huh? Is it
Tetrahedric.
Tetrajan? It's not tetraedric. Please revisit your notes. It's triagonal. Triagonal. 120 degrees. Triagonal. Tetrahedric is for sp3 hybridisation. Alkenes, the ones we're just from looking at. So when you're naming alkenes, same rules apply. Longest chain, substituent. Now here for this one, we don't have substituents. But in the next school, we're going to have substituents. And the ones with di and tetra thing is what we close and start looking at other things. Yeah. So in a case where you've been told to name an alkene, so an alkene with sp3 hybridisation, with bond angle 120 degrees, with theoretic shape that is triagonal. When you're naming these ones, you always, now the guide here is, please take note, the guide here is the liaison. Where you have the liaison, the double liaison, because we said sp3 or sp2 hybridisation is the one that results in a double liaison. So we say when you're naming such compounds, this is our guide. This is our guide where we're starting from. In other words, rule number 2, which says substituent, we can replace it now with the liaison. We can say we are going to consider the liaison that we have. Then we are going to also position the liaison if it's at position number 1, at position number 1, if at position number 2, at position number 2. Now, in this case, the longest chain, first of all, rule number 1, very important. The longest chain contains how many? So we will count. The longest chain contains 1, 2, 3, 4, and 5. So we'll be answering these questions ensemble simultaneously. This one also here contains, so the, what is this? Why did I even position this thing here? Anyway, it's fine. I will look for another example. Yeah, so the first thing is you look at the liaison, sp3, sp2 hybridisation, then you now count the number of carbon atoms. Always rule number 1, count the number of carbon atoms. We have 1, 2, 3, 4, 5. So rule number 1 formula is prefix, chaîne principale, then suffix. The rule is prefix, chaîne principale, suffix. Now, we have changed that. The suffix now is this. The suffix is this. Nightingale. The suffix is this. So if it was longer ANE, it is now ENE. So we're going to count. So we're saying these are 6. So it's going to be hex, hexa. So guys, I can't find my pointer for typing. I don't know what's happening. Okay. So we're saying it's a hexa. It's a hex, sorry, it's a hex. That's a prefix. So it means it has got how many? 6 carbon atoms. Someone is talking. There's a question.
And take 5.
There are 5. 1, 2, 3, 4. Oh, sorry, 5. Yes, 5. Guys, I'm also a human being. Don't take everything that they're saying. Gospel truth. So there are 5 carbon atoms. That's rule number 1. Rule number 2 was supposed to be look for the substituents. Now in this case, we don't have substituents. Huh?
It's not hexa.
Oh, yeah. Oh. This is what I want. When I make a mistake, you correct. So there are 5, and the prefix suffix is the prefix also the chaîne principale. The formula is the chaîne principale. Let me write it. Maybe you forgot it. So it is the prefix, then chaîne principale, plus its suffix. That's the general formula. So rule number 2 is supposed to state we're supposed to look for the substituent. Now in this case we do not have a substituent, but we have a liaison, double liaison. So when you're naming our alkenes, you're also supposed to take into consideration the position of the double liaison. The double liaison is also supposed to be taken into consideration. So in this case, it is at which position? So when you're counting, don't hesitate. I know there's no thingy. There's a carbon atom here. There is a carbon atom here. There is a carbon atom. So you count. It's at position number 1. At position number 1, you have at position number 1. Where is this? At position number 1. At position number 1. This is where the double liaison is starting from. This is where it's starting from. At position number 1. So when you're naming it, where is this? What's happening? Anyway, at position number 1, you have the double liaison. Or maybe let me use it. Let me say, you guys understand these things, right? If I say sp3, sp2, you know what type of hybridisation is responsible for what type of liaison. So sp2 hybridisation responsible for double liaison. So this is the first carbon atom here. This is where you have the first liaison. So you also name the position. Rule number 2 is you look for the position or name the substituent. Now that one was for the open ou bien ramifié alkenes. Now for our alcynes ou bien alkenes, it changes. You are supposed to look for the position of the double liaison. So in this case, the position of the double liaison is at position number 2. So whatever I'm telling you guys, here for this one, apply it on this one. It's the same thing. It's the same thing. It's just that this one is sp3 or sp2 hybridisation, and this one is sp2. It's the same thing. It's the same thing. So that's rule number 2. It's at position number what? Number 1. Then we go to rule number 3. Rule number 3, we are supposed to look for the substituent as usual, substituent, shanshan. Now we don't have substituent, so we end here. So if there was a substituent, we would have looked for the substituent.
I have a question, boss.
Hey, can you ask?
Yes, you said we also have to count where a carbon atom where a double liaison is.
Like
you get that part.
Okay. So let me just start. This is what I want. When you don't understand, please, when you do not understand, stop me, then I explain. When you do not understand, stop me, I explain. So that we go at the same pace. So we are saying this is the double liaison. So I'm saying rule number 2 states we are also supposed to count, or in other words, we are supposed to find out at what position do we have this double liaison. Now in this case, it's at position number 1. It's at position number 1. So if I draw another molecule or hydrocarbon, if it was like that, I'll count 1, 2, 3. So it's at position number 3. 1, 2, 3, 4. Position number 4. Same principles. It's just a type of number. We have. So I use prime for this one. I use blue. I'll use pink for this one. It's the same principle. Now here, it's just that we have in the place of a substituent, we have a double liaison. So we count with the lowest, it's always with the lowest index, with the lowest index always. So for this one, we are counting, it's at position number 1. You can't start counting from this side, 1, 2, 3, 4. No. This is where you start from. So you said 1, so you're saying it's at position number 1. The double liaison is at position number 1. Now, because we do not have a substituent, we do not have order alphabetic multiplication factors, now we go to the name. So the name of this compound would be a 5-chain compound hydrocarbon that has 5 carbon atoms. 5 carbon atoms. Then we are saying we're also supposed to look at the position of this double liaison. It's at position number what? Position number 1. Position number 1. Now, the suffix is what? Suffix is ene. So in other words, this was a general formula for finding the nomenclature for alkenes. But it's the same formula. Now we just add in 1 or 2 things. So let me just go another PowerPoint. I put a insert. What's happening? Why? It's very irritating. So the formula would be la chaîne principale. We have a prefix. We're going to have a prefix, which is also going to stand in for the chaîne principale. Then we're also going to have another one here. Just take the position of, I would say, SP juge. SP2 hybridisation, which is the double liaison. The position, at which position is the SP2 bond found? Then the suffix. So the name of this compound would be penta, ou bien penta, penta, which is also for the chain principal. At which position? Position number 1, so it's going to be penta. Guys, sorry, I wanted to, why is this thing fading? I'm not always on my computer, guys. What shall I explain? What was I supposed to do? Anyway, we'll just dictate the answer. Eh? So we're saying it should be penta. Penta. At position number what? Position number 1. Suffix. Now, because another way, this is the way I forgot to add on them. It's just a highlight, or maybe just one thing you're supposed to take note. If you have 2 vowels, I mentioned this last time here. If you have 2 vowels like A and E appearing at the same time, you're supposed to cancel this one here, like that. So now the molecule becomes the hydrocarbon, sorry, not molecule. Penta. In. Like that. Becomes like that. It becomes like that. So someone might ask a question. Say, okay, there. So let's move the position of the double liaison. We move it here. So we still consider rule number 1, chain principal. Rule number 2, look for the lowest index, that is for the double liaison. So in this case, we count 1, 2, 3. 1, 2, 3. So that's 1 at position number 2. We also count from this side 1, 2, 3. So we have at position number 3 and at position number 2. So it's position number 2 that's we're going to take this position here because it's the lowest index as compared to this one here with 3. This is 2 and this is 3. So 2 is the lowest index. Then there's no rule number 4 where you position the substituents. There's no rule number 5 if they are multiplication factors. If there's rule number 4 where you apply the alphabetical order and all those things. So here it's only the position of the liaison that we're going to look for. And the formula is the prefix, which also stands in for the chain principal, then the position of the double liaison, and the terminaison. The terminaison is a suffix. So in this case, for this one, it now becomes 2 in, like that. Pent 2 in, because the double liaison it is at position number 2. The double liaison is at position number 2. Any questions so far? Because what you've done here is actually the same thing you do for this one. Any questions so far? Any questions? Alhamdulillah. Then maybe another thing that I am going to add will be another example. Another example on these things, Another example on these things would be, take for instance, we have a double liaison there, and we have another double liaison there. Maybe I even cover another topic ahead, so I'll put that thing in there. So, rule number 1, chain principal. Chain principal. The reason why I've highlighted this is because I know you guys now understand which one is the chain principal, because you're supposed to count with a low. You're supposed to count all of them. Please always count. I'm used with this because I've done this over and over again. I know which one is the chain principal. Now for you guys, because it's your first time, you're learning these things. So you're supposed to count. Make sure you just take your time. You count. You say 1, 2, 3, 4, 5, 6. With time, you get used also. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3. Like that. It becomes easy. With time, you know that this is a chain principal. Then we go to rule number 2. Rule number 2. Oh, before we forget, we're saying 1, 2, 3, 4, 5, 6. We have 6. 6 carbon atoms, 6 carbon atoms. Then we are going to go to rule number 2. So a 6 carbon thing is called what? A hexa. A hexa. Then we're going to go to rule number 2, the positions of the indices. Now in this case we have rule number 2 is where we have the indices, where we have the substituents, and we have a substituent here, and we also have the liaison. So now what do we do? A liaison will always come first, then a substituent. A liaison will always come first, then a substituent. A liaison will always come first, then the substituent. So when you are counting, you count, you say, okay, which one has the lowest index possible? So you have 1, 2 at position number 2 here. You have the first liaison, position number 2. You come here on the other side, 1, 2. You have position number 2 on core. You have position number 2 on core. Now, because you're saying the liaison comes first, then later on the substituent. So it is a substituent that is going to qualify which liaison will come first. Please take note. The liaison will come first, then the substituent comes second. We are still on rule number 2. Right? Rule number 2 is the position of the substituent and also the position of the liaison. Now, in a case where you have a liaison, double liaison, and a substituent, it is the double liaison that is going to come first, then the substituent. Please take note. It is the double liaison that's going to come first, then the substituent. So in this case, because we have the same index, the same thing like that happened to the other question there. You have at position number 2 and at position number 2 prime. What is going to qualify which direction? Be it right, be it left. This direction, or bien this direction is the substituent. The substituent is going to qualify which direction we are going to consider. Now, we count foot. This is 1, 2, 3. We have at 3 prime. So this is on the right, and this is on the left. So when the direction is left, from right to left, we use prime, and from the left to right, we use numbers without prime. So we have this is at position number 3, number 4 prime, 4 prime. So it change la couleur. We're going to use which color is that? No, red. This red, yeah. So no. Blue, okay, blue, I think blue. So same principle. This is number 1, number 2, number 3, and number 4. So we align them, right? We align them. So this is a box from left to right. Please, you guys, another thing. These methods I'm showing you, they shouldn't be methods that you, when they ask you a question, you start drawing to my boxes. No, the idea behind this is just to facilitate understanding. Practice these things, then with time you get to understand how it's done. Also, to go to school, I pass a question in nomenclature. You even draw to my boxes. No, that was drawing boxes. No. You don't do that. Now is the time to practice. When you go to school, you just look at the molecule and know the positions, and the name comes like that. Not to my boxes. These things are just to help for understanding. Because up now we are building a foundation for the faculty for the école. So no. Position number 1, 2, 3, 4. 4 prime. At position number, this is the same thing. 1, 2, 3, 4. The same thing, Tef. 1, 2, number 3, prime, and number 4, double liaison. So, okay. Now, these are the positions of 1, 2, 3, 4, 1, 2, 3. Okay. So we are saying,
what is at point 3 from the left? Because I think the methyl
I think I've made a mistake.
4 and also the second double liaison from the left is at number 4.
Interchange the number steps. So 1, 2, 3. At position number 3, at position number 2, we have a double liaison, which is here. At position number 1, 2, 4, we have, oh yeah. So yeah, nice observation. What was that? What was that? Are you programming?
No.
Okay, boss. Thank you very much. So 1, 2. At position number 2, we have the starting of the double liaison. At position number 3, we have another double liaison. No, we don't have a double liaison at position number 3. We have at position number 4. Yeah, Mr. Conan, thank you very much. And at position number 4, this is where the double liaison is again. Because this is position number 4 for the substituent, and it's also the position for the double liaison. Thank you very much, Mr. Condon. Thank you very much. Then on the other side, we have 1, 2 for the first double liaison. Then we have position number 3 prime for the methyl group. Then position number 4 prime for the other double liaison. Now the question would be, we have the same indices, please. I will say this row again. Hey? When you have a double liaison and a substituent, the double liaison comes first, please. The double liaison comes first. Then later on, in a case where you have 2 indices that are the same, like 2 and 2 there, it is now the substituent that is going to disqualify, or bien is going to qualify which order, or bien which route we are going to use. Is it the left to right or the right to left? It is now the substituent that is going to disqualify which one is going to be the route we are going to use. Now, some of you might have a question. Say, okay, now what if we do not have the substituent? You still count. The rule still remains. You count which one has the lowest substituent. So you say 1, 2, 3, 4, 5. Same thing for 1, 2, 3, 4. So you take the one with the least index, like the lowest index possible. So it's going to be on the other side. Now, in this case, we have a substituent. The substituent in this case disqualifies the other and qualifies the other one. Now, we have 2 indices here that are the same. 2, 2, 2, 2. We disqualify them, we cancel them, we rule them out. We now go to the other one, which is going to be 3 and another 3 here. Now, because we're saying this one, the substituent is what's going to qualify the other one. When you count from this one here, from this position, you say 1, 2, 3, 4. The substituent is at position number 4. And when you count from this side, it's at position number what? 1, 2, 3. Now, 4 and 3. Which one is the lowest? It's 3. It's going to be 3. 3 is our lowest substituent. Then we go to the last one, where is the position of the last liaison. So taking this route, we have 1, 2, 3. At position number 4, we have the last liaison, which is this one here. And again, at position number 4, 1, 2, 3, 4, we have the other liaison here. So now, because we already have this one here that qualifies the other, this becomes the index, or beyond the indices we are going to use to name this compound. I know there are a bit of questions on this one, but this is just a highlight of how nomenclature on alkenes is done. So now, if we're to give the name of this compound, we are saying the rule is we're going to look for the chaîne principale, which is going to be the prefix, also known as the chaîne principale, plus the position of the double liaison and the suffix. That's the formula. So we count, we say 1, 2, 3, 4, 5, 6. We said it has got 6 carbon atoms. We go to the other part of the formula, which shows us the position of the double liaison. We are saying at position number, we're using this route. At position number 1, this is number 2. And at position number 4, we have a double liaison. At position number 2, this is position number 2. 1, 2, 3, 4. At position number 2 and position number 4, we have a double liaison. So position number 2, position number 4, we have a double liaison. Now, the double liaison, we have 2 double liaisons. What did I say about things that occurred 2, 3, 4 in organic chemistry? We do not say times 2. We use multiplication factors. So the multiplication factor we're going to use here is di, because we have 2 double liaisons. We have 2 double liaisons. We have this one here. We have another one there.
It's 2 o'clock.
If we had another double liaison at the far end, like that, another double liaison at the far end, we would have said 3. 3 shows. Now, so the formula now becomes hex n 2,4 di. Now the suffix is what? Because this whole thing here shows the position of the double liaison. Now, what's our suffix? Our suffix will forever be E N A, because now we are discussing these guys here. These guys. This is what we are discussing on today. So it's going to be 2,4 diene. The die shows that you have two sp2 bonds here. You have this one there. You have another one there. So it shows that you have 2 liaisons. Now, we have not finished naming this compound. This was just for the chaîne principale. Then we're not completing this here. We have another thing here. We have another thing here, which is a substituent. Now the substituent is at position number 3. So it's going to be 3-methyl hexa 2,4 diene. Now, someone will ask foot. Now, there's here you have a vowel, and here you also have a vowel. Now, because you have a vowel and there is a consonant here, you see, in organic chemistry, we apply everything. Everything you learned, English, all those things, mathematics, we apply them here. Because you have a vowel here and a consonant. You know what consonants are? Consonants. When you remove the vowels from the alphabet, the ones that remain, consonants. So the D here and the A, there will be no interaction, or we'll say there will be no reaction. So the A will still remain, and the D here will remain as well. Because of the D, the A remains. But if we did not have a double liaison, that would stand in for 1 liaison, and this would have been our suffix. This would have been our suffix. So the same rules we have applied for this one here. It's time up, but I just want to just note, we'll learn these things in detail, don't worry. The same rules we have applied for this molecule here, for this molecule here. For this one here. For this one, I'll draw it again, How many carbon atoms? 1, 2, 3, 4, 5. It had 6, eh? Like that. Like that. The same rules we applied for this molecule here. Sorry, not molecule. It's organic compound. The same rules we applied for this organic compound will be the same we are going to apply for this one. We are going to look for the chain principal. We are going to name it according to the position of the triple liaison. Now it's not double, but triple liaison. So this one has position number 1. So you consider the triple liaison to be your guide for the positionings. So you have a triple liaison there. Then you go in this direction. So for this one, we are going to say 1, 2, 3, 4. 1, 2, no, sorry. Last time I showed you that there's 1 here. There is another one here. Then there is this one here. So it's going to be 1, 2, 3, 4, 5. So it's going to be a 5-chained hydrocarbon is called what? A penta. A penta. This is a prefix. Then at what position do you have this triple liaison? We have it at position number 1. Then what's the suffix? The suffix is Y, N, E. Safi. That is how you do nomenclature on alkenes, alkyls, 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 alkyls. This is how you do nomenclature on alkyls. So if the double liaison, if the same thing, the same rules apply. If we had another triple liaison, takes for instance, we have another triple liaison on the other side. When it comes to this one, yeah.
Why Gangalaka paint instead of butte?
Butte, how many? Come on, 1, 2, 3. 1, 2, 3, 4, 5. There are 5 carbon atoms, boss. Is it me that's is it me that has gone wrong? Sure, just wait.
Yeah, there are 5.
I thought this is like a straight line.
No, let me think. If it's SP hybridization, we're supposed to have 2 double liaisons ensemble, n'est-ce pas? So just a minute. No, as in you have a point. Let me just clarify on something. You have a point, because sometimes when you are given a molecule like this one, we're also supposed to consider the position of the other carbon atom that is responsible for the SP hybridization. Now, in this case, if we just consider this carbon atom here, it means is ankara wrong. If we just say 1, 2, it will be wrong, because this one here has SP thrice hybridization, and this carbon to carbon liaison here has SP hybridization. So it means we are going to have 1, 2 that are responsible for the, let me just highlight it. This part here, where you have the SP thrice hybridization, then you have this one here with SP hybridization. So no, don't worry. Well, today I was just introducing this part on how you name normal chains of alkyls and alkenes. So from what I have explained, have I clarified anything, bosses? Is it okay? Or maybe you still have a query? Mr. Samuel? Samuel?
Yes, bosses, yeah, it's okay.
Okay, yeah. So this is the nomenclature. Now it becomes pent. It now becomes penta for the prefix, and the position is at position number 1. Then the terminaison or bien the suffix is YNE. The same rules we applied. Please take note. The same rules we applied for this molecule. You have a substituent, you have a shani, they still apply. So in the next lecture, we are going to learn now how to maneuver around molecules like this. Sorry guys, we're using molecules, not molecules, hydrocarbons. Hydrocarbons that have got a double liaison and a triple liaison, maybe with a substituent. So in the next lecture, we are going to learn on these kind of anomalies. So for today, we are done. Then tomorrow, I've been told that tomorrow I'll be teaching those that are taking biochemistry. Please, I have a question for you. This question should be done as research, because tomorrow when I come, I don't want to, no, I start explaining what you've already done. No. So the question is, those that are doing biochemistry, the question is, what is the difference? So you give me the answer in the inbox. What is the difference between fructose, galactose? Let me write them down. So I'll share a screen again. What's the difference between, so those that are taking medicine, if you're not taking medicine and tomorrow you're doing biochemistry, please take this serious, because my nomenclature biochemistry, so I need you to understand one thing, so that when I come tomorrow, I know where to start from. So the difference between the following: the difference between fructose, galactose, glucose, mannose, okay, for this one I'll say D mannose and L. So for those guys that are doing organic chemistry, this is not you can kite. Yeah. So let me even stop recording.